Hello, algebra, and welcome to a new unit. Unit 3, we're going to be looking at systems of equations. We just got done with linear equations, and we're moving on to something very similar in systems. So today, I want to explain what a solution looks like for a system of equations, and then we'll solve a system of equations by graphing. So we're actually going to use something that we used in the last unit, graphing. So some vocabulary real quick. A system of linear equations, which I will refer to as simply a system. I'll just say system. When I say that, I'm talking about a system of linear equations, is two or more equations together. Typically, we're going to have two equations. You could actually have more, though. A solution to a system is any ordered pair that makes all equations true. So just like in the first unit with solving equations, a solution is a number that makes one side of the equation equal to the other side of the equation. And back in unit 1, it was a number, a single number. In this unit, because we have two variables, we need an ordered pair because we have two numbers that we have to replace with, or two variables that we have to replace with numbers. So we're going to take a look at that with this first couple examples. Is 3, -4 a solution of the system? It's a system because there's two equations right there. So what we're going to do is we're just going to take 3 and put it in for x, and -4 and put it in for y, and see if the two sides are equal on both of them. So I'm going to put -4 in for y, and we're looking to see, are they equal when I put 3 in for x? So the left side there is -4. 3 minus 7 is -4, so it works for the first one. That's good. Now what that means is that point, 3, -4, is actually on the line y equals x minus 7. So if I would graph that, this line would go through 3, -4. All right, now let's do the next one. This one's in standard form, but that really doesn't matter. I'm just going to put 3 in for x and -4 in for y and see if it equals 3 when I simplify it. So 5 times 3 is 15. 3 times -4 is -12. 15 plus -12 is 3. Does 3 equal 3? Yes, it does, which means the point 3, -4 is also on that line. So is it on both lines? Yes, it is. So the point 3, -4 is a solution because the point is on both lines. Now, another way of saying that is that point makes both equations true. Okay, the fact that the point is on both lines is why it is a solution. All right, so let's try the next one. -1, 2, is that a solution? So I'm going to put 2 in for y and -1 in for x. So simplify what you can. 4 times -1 is -4. -4 plus 6 is 2. So 2 equals 2. We're good with the first one. Second one. 3x, x is -1, plus y, and y is 2, equals 1. So -3 plus 2. -3 plus 2 is -1. Does -1 equal 1? No, it does not. So because -1, 2 is not on the second line, we would say that the point -1, 2 is not a solution because it is not on the second equation. Right, so it's got to be on both for it to be a solution. All right, so now in those two examples, I gave you two possibilities, a possibility for each one on whether it was a solution or not. What happens if I just give you two equations and say, find the solution? And you have to start with just an equation. Well, let's graph this. We just said that an ordered pair is a point that's on the line. Let's graph these two lines and look at all the points that are on each equation. So we'll do the first one here in blue. So we should know how to do this. The y-intercept is -5. Slope is 1/2, up 1/2. One thing I am going to recommend you do is keep making more points, and you'll see why here in a little bit. Put as many points on the graph as you can. All right. So there's the one. Let's do the other one in red. 3 is the y-intercept. -3/2. So down 3, right 2. Down 3, right 2. All right, so all those points that I just plotted in red and more are solutions to the second equation. All the points that I marked in blue and more are solutions to the first equation. Is there a point that's on both lines? Hopefully you see that that point is right there. That point is on both lines, which means it works for both equations. What are the coordinates of that point? It is 4, -3. And that right there is my solution. If you take 4 and put it in for x on both of them, you'll get -3 for y on both of those. All right. Next one, -2x + 4. 4 is the y-intercept. Down 2, right 1. Remember, that's a fraction. Down 2, right 1. Down 2, right 1. Just keep going. And there's my first line. Second line. We're doing red, but it's not ready to go. I could use intercepts here. I wouldn't recommend it. I would put it in slope intercept form, but you could use intercepts here. So subtract 3x, I get -2y equals -3x + 6. We did this last unit a lot. You should be good with this. If not, this is more practice. Negative divided by negative is +3/2. 6 divided by -2 is -3. Okay. So -3, and then up 3, right 2. And you see that they already have crossed, so I can kind of stop making points. Where did they cross? Right there. What are the coordinates of that point? That would be 2, 0. And that is the point that would, if I put it in for x and y, it would work for both equations. I think I've made this pretty clear, but let's go to the back just to make sure that I did. Where do you find the solution to a system of equations on a graph? At the intersection of the two lines. Big idea for today is just find the intersection of the two lines. Where they intersect is the solution. All right. All right, let's look at 2 more examples here. Because some weird things can happen. These are called special cases. Let's graph them both just to see what's going on. Again, I'll stick with the same idea of blue first. -3, up 4, right 1. Up 4, right 1. There's the first one. Second one, I got to get in y-intercept, slope intercept form, add 8x. So I get 2y equals 8x plus 8. Divide by 2, divide by 2, divide by 2. I get y equals 4x plus 4. Up 4 doesn't really fit, so I'm going to go down 4, left 1, down 4, left 1. Oops. Yeah. Okay, what do you see? Hopefully you see that there's no crossing. Which point is on both lines? There are none. Okay, that should make sense based on the last couple lessons of our previous unit. Slope is 4 in both of them, and the y-intercept is different. These lines are parallel. Okay. Since these lines meet nowhere, no, it's not on the screen right now. It is, but the bottom part, we say that this has no solutions. If they don't cross, there's no point that's on both. All right. Yeah, sorry. There's no solutions. There's no point that's on both lines. It has no solutions. Right. We are looking for where they intersect, and if they don't intersect, they don't have any solutions. All right. What is the other special case? Well, let's look at that one. Let's get blue. 1 is the y-intercept, down 3, right 1, down 3, right 1, up 3, left 1, up 3, left 1. And then let's switch to red. Again, we're going to subtract 9x. So 3y equals negative 9x plus 3. Divide by 3. I get y equals negative 3x plus 1. 1 is the y-intercept. Down 3, right 1. Down 3, right 1. What are you seeing? Which point is on both lines? Aren't all of them on both lines? So since those lines meet everywhere, they're the same line, right? Look at the two equations. They're the exact same line. And the exact same line is going to meet everywhere. We say this system has infinitely many solutions. Okay, so you can have that situation pop up as well. I'm going to summarize what's going on here in the next part. If two lines have different slopes, okay, so two lines have different slopes, that means they will intersect. And if they intersect, they have one solution. That's what's going to happen majority of the time. All right. If you look at the previous two examples, both of those right above this summary had the same slope. Okay. So if they have the same slope, that's a special case. If they have different slopes, it's easy. It's one solution. Okay. Well, if they have the same slope, well, it could be one of the two special cases. What differentiates them? It's the y-intercept. They have the same slope and different y-intercept. Then the lines are parallel. And if they're parallel, they have no solutions because they never meet. If two lines have the same slope and same y-intercept, then we say those lines are coinciding. You don't really need to know that word, but I'll say it. They're coinciding, which just means they're the same line. Okay. And have infinitely many solutions. And to see if you understand this idea, we're going to look at the last question here. How many solutions does this system have? The three choices are one solution, no solutions, or infinitely many solutions. And we can tell without graphing if we just look at their slopes. And then if their slopes are the same, we look at their y-intercepts. So the first one, the slope should be pretty easy to spot. It's -5. The y-intercept, since it's already there, I'm going to write it. It's -7. Second one, I got to do some work. I got to subtract 10x. So it's going to give me -2y equals -10x plus 14. Divide by -2. I get y equals 5x minus 7. So what's the slope? It is 5. The y-intercept is -7. Be very careful. A lot of people think they're the same except for their signs. Well, if their signs are different, their slopes are different. So if the slopes are different, how many solutions does it have? One solution. Okay. That concludes lesson 1. We're going to move into a new way of solving in the next lesson, and then yet another in the third.